Hello, I am Jacob Hughes, and this is my lab report for Physics 2212 Lab 2. The purpose of this lab was to use the charge tape model derived in the previous lab to compare the values of the point charge model to the line charge model, and the equation used to do this is electric force is equal to kq squared over d squared. The results gathered were that the calculated Q value from the line charge model is 1.938 times 10 to the negative 8 coulombs, with an estimated more accurate Q value of roughly 2.04906 times 10 to the negative 8 coulombs. The assumptions made before starting this lab were that the two pieces of tape had roughly the same charge, tape B could be modeled as a point charge, and that air resistance was negligible. The calculations initially are very similar to those in Lab 1. We start with our length of the tapes being 16.6 centimeters, the distance between the two tapes of 2.4 centimeters. We can then calculate the mass, which is 1.66 times 10 to the negative 4 kilograms. Using all these values, we can thus calculate force due to gravity being negative 1.63 times 10 to the negative 3 newtons. Then finally, we can calculate the point charge value being Q equals 1.021 times 10 to the negative 8 coulombs. Conversely, we can then plug in to the line charge equation, which gives us a value of Q equals 1.938 times 10 to the negative 8 coulombs, which we can see from our code here that it gives us a much more accurate value of electric force when compared to the gravitational force, compared to our point charge value, which is roughly 3 orders of magnitude higher than that of the line charge value. Finally, we can calculate, or estimate rather, a more accurate Q value of roughly 2.04906 times 10 to the negative 8 coulombs. This was gathered through a process of elimination and some guess and check, and this does give us a much more accurate value of electric force. Here's my code. On the left, you can see the variables that were initialized, specifically the charge variables, or charge values rather, starting with those calculated outside, and then finally the estimated value of Q. Underneath it, we can see where we calculate the electric field. On the right, we can see where the lines that represent the charge directions and magnitudes are created. Up top here, we can see where the models representing the tapes are created. Underneath it, creating some more vectors for the field and electric force. And then finally, we calculate our net electric force and gravitational force and print out the results. So the similarities and differences were that my calculated value for Q of 1.938 times 10 to the negative 8 coulombs is somewhat lower than the estimated value of Q, which is roughly 2.04906 times 10 to the negative 8 coulombs, but it is, however, much more accurate than the point charge calculation of 1.021 times 10 to the negative 8 coulombs. This dissimilarity stemmed from modeling tape B as a point charge and using a finite number of subdivisions in the line charge calculations. In conclusion, in comparison to the data from Lab 1, the line charge model is significantly more accurate than the point charge model. The line charge model, however, is not completely accurate. Additionally, what if I had modeled each of the tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with the line charge model. As you can see, the point charge model of 1.021 times 10 to the negative coulombs and the line charge model of 1.938 times 10 to the negative 8 coulombs has a percent difference of 61.98%, and previously in these slides you can see the differences between these two models and how vastly different they are. Why do they differ? The point charge is much more simplified and estimatory compared to the line charge model, and the line charge model thus is much more likely to be accurate.